Hi, today we're going to have a quick look at my C deinterlace tool, which was a tool that I wasn't expecting to make. It was an unintentional creation because I was trying to do a quick tutorial on another one of my tools, C Rebuild. As I was creating a tutorial for it, I realized that the footage that I was planning to use was interlaced, so I decided that I wanted to solve that problem very quickly. Now the tool has actually become more than what I originally did, so we'll have a look at the footage first, then we're gonna open up the tool at the end and have a look inside of it. This tool will be free on Nukepedia, but please do come and support me on Patreon or YouTube. Very much would be appreciated. Alright, so let's get into it. So our footage is pretty interlaced. Yeah, so you get a very good idea of it. So I'm not sure why that was, if that was interlaced because of being in the camera or if it was bad encoding. This is footage from quite a while back. Could be either, to be honest. So it was done before I had done my first showreel after being in industry, so it was pretty early on. So probably didn't get some technical things correct. Alright, so first off, this was inspired by I think it was a YouTube video. So this is the video that I came across for the deinterlacing idea by Frank Reuter. I'm totally saying it wrong. Those of you who don't know who Frank is, to my knowledge, the guy behind the creation of Nukepedia, which is a incredibly useful website, thousands of tools available. Yeah, should check it out if you haven't already. I'm assuming most of you know it. But anyway, for those who are uninitiated and uninformed, yeah, check it out. So with that, let's dig into it. So, I've come up with 3 different methods for dealing with deinterlacing. I originally was only going to leave this at 1, and then kind of decided to do a second one for people because I wasn't over the moon about the first one, which was the one I stumbled upon. And then I decided to make more of a more correct version in my mind, and then based on what some people were saying on some of the forums, there seems to be a bit of dispute about what the frame range should be for deinterlaced footage. So yeah, I made a third output so it can also handle that kind as well, just so everyone's able to get what they want out of the tool. So what we'll do is, first off, we'll pull up the deinterlace tool that is in Nuke. Now the only way to get the deinterlace tool is to actually go to your all plugins and hit update. Once you've hit update, you will be able to find it. If you can't find it this way, the other way is to hit X on your node graph and then make sure that you have the capital I and capital D. It is case sensitive. And spell that right, that's also a slight problem. There we go. And those are 2 different ways of calling this node. This node is a legacy node, hence why you have to call it this way. Now this node produces this kind of result, which is pretty suboptimal. It's a good starting point, and it is actually the starting point that I utilized. So let's have a quick look inside this one. So it has 2 field selects, one on odd and even, retrospectively. Then it's doing a reformat, because when you do your field selects, it just kind of crops out the other ones. It doesn't stretch the image, it just straight crops them. And then it's doing a dissolve, which is why you get that kind of nasty blending of frames going on, which, yeah, isn't how interpolation should look. Sorry, how deinterlacing should look. So, let's have a look at the methodologies. So I've got the three here. There's a nice little drop-down menu on it for type. Scanline integration looks like this. Scanline integration is actually grabbing... Scanline, I think, is the most accurate one out of all of them, and it's incredibly fast to deal with for what it is. There are other methods in here that are much slower. Come on, Nuke. Might turn on my full frame scans for this, just because I don't really want to have to get penalized for zooming in and out. So it runs alright. It's not amazing. It's not blink. But how it works is in our interlace footage, has 2 frames interwoven, where on the odds there is 1 frame, and on the even scan lines there is another frame. Now a scan line, I'll get into and be able to show a bit more of a representation because I had to create one. But essentially what I'm doing is kind of pushing 1 frame back and then separating them out by their scan lines and then putting them back together. We're also doing a filter on top, so you can actually control the quality of the what's woven back together. So if we go impulse and we go to Nacos, you will see a slight variation. There is a little bit of movement, but that's just based on the actual filter, how it's actually being filtered. Yeah. I also have this lovely little thing that I sometimes use called P color space, which is instead of going log-lin kind of conversions, this is just doing a power of conversion. So that way you don't get sharpening so much when you... Well, you get sharpening, but you don't get it going into nasty values when you use the super sharp kind of algorithms. And it's scalable, so you can kind of pull it up and down to be able to vary that. But remember, because this is doing a multiplication and division, you go to 0, divisions tend to have a problem with 0. So, yeah, but you can see around the beard area how that is affecting the sharpness. So I normally just leave it on 0.5 and that goes 4, just so we're really in a nice kind of safe space, we'll go with for sharpening. So there's method 1, and it keeps this methodology keeps the exact same frame range as the original footage. Now, just keep in mind that when you zoom in and out on Nuke, it doesn't read all of the scan lines, hence why when I come to like this, you'll notice it pops in as if one is more correct than the other. If you go further out and further in, you'll actually find there are some interesting moments in how our viewer is actually handling stuff, which is why it's always not good to do things in proxy modes and whatnot, unless you like doing it on the fly and trying to keep things light. But if you're trying to do actual QCing of things, yeah, don't use proxy mode. And make sure you're at a, a 1-to-1. So, or further in than the 100%. I guess that's better phrasing. So yeah, you can see this one is picking this one as the predominant, and you can invert the phase on the Scanline integration. which is more about swapping around these, which one is correct and which one isn't. You might be able to see this, I hope so. It's only very minor. Yeah, you might be like, oh no, this one technically needs to be, but it is running in odd first then even, which I believe is technically accurate because from all the actual physical scanline converters I've used, which I haven't used one in a number of years now, but yeah, that's how they function. So, and also on the first frame, it will utilize one of the frames as opposed to two, because it only has half the information to be able to deal with it. So you will notice a small sample quality drop. The same with the last frame, because it doesn't have an additional frame to be able to fill in the rest of the data. But it shouldn't prove any problems, though. You will still get an image out that is, you know, passable in a lot of circumstances, like for what you're dealing with, like, yeah. And we are also, like, if you're doing like the filtering like I am, then you will find it is slightly improving the quality of those frames, arguably. Alright, so that's method 1. Method 2 is temporal interpolation. This is the actual method that I stumbled across. This was not an intended outcome. I just came across it. So normally it looks like this. So what this one is doing is actually grabbing both of the scan lines and then trying to solve between the two. Depending on how far apart they are from each other, it may be successful or unsuccessful in this. At the moment I'm using this in regularized motion vectors. It's doing a pretty good job, but you see, like, here's the nose of one of those scan line images and here's the nose of the other one. It is actually popping it bang in the middle, so it is actually interpolating between those two frames. So for those case scenarios where someone's like, no, it should be between those for whatever reason they're arguing that point, now you have an actual solve for that. Be mindful, it will create some artifacting, and you can switch to localized for those ones if you wish and kind of patch the regions. I would strongly recommend, if you're switching to local as the motion vectors approach, I would recommend that you do some sort of stabilizing of it and then match moving it back, just to help that approach. It's actually quite a good approach, but it just needs a little bit more assistance than regularized does. So with that, we'll move on into the final one, which is the one I just implemented, which is double length. Because a lot of people seem to think, and I don't necessarily agree with them, but we're going with the client wants, so the client gets philosophy. Think that, you know, because there is two frames, that the length of the frame output should be double, which I personally don't agree with, but there might be case scenarios that I'm unaware of that people have had, so I put it in here because it's not a huge problem to actually build this part. So, oh buddy, oh. For those of you who can't tell and see, I have my little buddy Rufus here today. He's just chilling on my lap. He gets a bit anxious every now and again. He's very young. Oh, it's okay, buddy. So yeah, so the reason I don't think this is a true reason is because in this exact case scenario, you'll notice these two frames are pretty much the same, because they're the, you know, one's the even, one's the odd of the same image. Now you might have had a scan line that was converted in a slightly different manner, so yeah, there may be a case scenario that I'm not aware of where you might need that to be double the length. Then you can obviously, you know, reduce it down and use Chronos and whatever else to fill in additional and speed ups and all that stuff. So, whatever. The tool does what it needs to do, and it ticks the box for, you know, 3 different methodologies, and all of them are a nice improvement. Things to note, all methods make sure the resolution stays the same. Not all methods retain the correct frame range of the original, as double length does what it says on the tin. Oh, buddy. You're right. But yeah, there we go. So we're going to dive into it now. So there was the de-interlace tool. Let's leave it there. Out of this, I pretty much took the idea of the field selects and the idea of reformatting, but yeah, I didn't like this kind of approach to reformatting. So there's another tool that I'm working on, which is a reformatter, which I'm going to release free as well. So it's kind of in here. So C, de-interlace, here we go. So plate comes in, we're picking, oh buddy, it's okay. Alright. So we're picking RGBA, this is literally this part up here, so we can reduce it down. Alright buddy, alright, yeah, you a good boy? You a good boy? Yeah, you're a good boy. Oh, you're a tired boy. Okay, can I talk now? You're gonna let me talk? Okay, let's try that again. First off we have a frame range, just kind of stipulating the frame range, what is first, what is last frame, and the values on the actual thing, which is giving it that nice kind of overlay, and time clip just to ensure that we have data on either side of our frame range, just so that there is actually enough data to create the first frame and the last frame. Otherwise, without this, it may not actually have enough data to do that, as interpolation, as de-interlace, can have that kind of problem. So then we're using field selects to select the odds, the even fields, similar to the built-in tool. Image comes out like this because it's just deleting the in this case, or the odd ones, or the odd scan lines. Whereas in this one, it's deleting all the even ones and just leaving the other one, which means that it's dropping its resolution by half, which is kind of the whole point of interlace. So we need to scale that back up. Now, I'm actually going to build this into a tool, and it's going to also be available on Nukepedia. I'll probably call it Reformat 2. This allows us to reformat the actual input to the format of the other. So the CPOW is also another tool in my creation, which isn't that amazing. Just allows users to do a power of conversion, and with these I'm actually inverting one from the other, so that as I change one, the other one changes. So have a quick look at that expression, just for those who are interested. It's just that easy. Grabbing that value, putting it in, and doing that. That way it inverts it. So which also means that when this goes to a value of 0, that it has some issues because you're dividing by 0. So moving on. The reformat is literally left on to distort. It doesn't need to be in any other setting for this specific case scenario for the tool that I'm going to be creating. That's going to be on Nukepedia. I will have, you know, these raised up so people can actually have choices over them. So that means that we then end up with each image converted. Now I'm just going to switch this filter to impulse for the moment, just so we can see what it's actually doing. When we zoom in, we can see it's actually stretching our pixels, so we actually get 2 pixels each for each and every single one. And that's the same for the alternate. So this is kind of the outcome, because you only have half the information and you're doubling it. So now we get to this point, and this is where the similarities between all the different methods kind of stops. So in the Scanline integration, we actually take these to this little area here. This is the Scanline integration. So we do a frame range again. This is more just to ensure that things are playing ball the way that we want. Once we've done this, we do a slight positional offset. Actually, sorry, no, I'm grabbing the wrong one. So we're doing the Scanline integration. So we do a slight time offset because we want them to actually be on the same frame. So there's a same frame now. If I zoom out, you can see that it's actually 2 of the same, but it's different pieces of data for the same image. So we then do our little range to ensure that it plays ball the way we want, and then I'm using a position tool, which is just like a transform, and I'm just pushing it up by 1 value. It's a bit of an older node, and there's our image being pushed between the 2 different Scanline outputs. Now, you can create some issues around here, but we deal with those a bit later on. It's not a huge drama. So the next part of the Scanline integration is we are doing a scanline. So scanlines look like this. They run from left to right and then top to bottom. And we're taking each row and separating them into odds and evens. Here's a nice little sine wave expression that allows us to get a 0 for our odds and a 1 for our evens. So as we go down, it doesn't change as it goes horizontally, but as it goes vertically, it changes value. So the frame check is about ensuring that the first frame, that if we are on the first frame or on the last frame, or add the sequence altogether. So that way we know for the first frame and last frame how to actually, that we don't have complete data, so we can actually fill in the blanks that are not there. So with that, do that by multiplying it when we're actually in the frame range, and then we take this down and we grab each one of our various completed frames, and then we multiply it by that. Now we have a tool here for actually inverting, so that's our phase inversion. So if you want to vary between the two, that's what that's about. And then we're multiplying both of those and then plussing them together, which gives us the alternate information. Then we're grabbing the average of our alpha. So if there is an alpha, because we are also using our alpha over here to over and under, well, over and over our original complete frames, just for our first frame and last frame, and that's how we kind of handle that little problem. And then we're shuffling or copying back in the alpha. given it has an alpha. In this case scenario, it doesn't. So that's the first method, and then we're pushing it back into the right position. So that's the first method, which is the Scanline Integration. Then the Temporal Interpolation one is interpolation, same word, is done through getting both of our images again, where we got to at that point. This time we are ensuring the frame range again is in the right spot, but we're not doing a time offset this time. We actually want it to be in its current frame. So we want these two frames, and then what we're doing is we're doing a little positional move so that it's, you know, physically in the same space, and then we're appending the clips, so we have a list of 2 clips then, and we're readjusting the frame range so that it actually understands the frame range, so it's not looking beyond the frame range. Then we're using Kronos set with a 1.5, so it's in between those, and it's then doing its motion vectors on that. So that's why we have all this here, because this is how it actually does that. Now, we get around the whole timeline issue by then later on down here copying it back into our B pipe, which actually has our frame range data. So that is actually how it switches back to knowing where to look in the time frame. That's how we actually solve that whole problem. So we'll just do the 1-2 between the plate. So you can see in between those, it's smushing them together. It's doing a pretty good job on this frame because the frames are similar enough that it can do so. If they're not similar enough, it will struggle. But that's like any motion vectors. Yeah, you will get some artifacting with this, but you can also, yeah, get a pretty good result for what it is. Moving on to the final approach, which is the double length. The double length is this little setup over here. So again, we're grabbing our 2 frames as before. And this time though, we're doing a retime and we're saying half the speed, so it's twice as many frames. And we're doing that to both of them. And we're doing their positional move so that they are going to physically be in the right location. So get to one of the in-between frames. Here we go. So these 2 frames are more or less the same data, which is why I'm not a big fan of this approach, and I don't believe it's an accurate approach. But as I said before, there might be reasons where the interpolation is being done in a slightly different manner. So for that sake, and for the, you know, the client wants, the client gets kind of purposes, I've gone ahead and built this pipe. So how that works is, so it's just doing the sine wave. We've got the first frame so that we're guaranteeing wherever the first frame is, it's always going to be on a 1 that it starts on, unless we turn our invert order on, which will, it's a toggle, so it's a 0 or a 1 value, and then we're just doing a sine wave that is going to oscillate per frame between 0 and 1, so it ends up being more like a sine wave, I mean a square wave, which we could probably show in the curve editor. Yeah, there we go. So it's doing quite fast oscillation. So when you actually zoom in, per frame is oscillating between 0 and 1, and you can see that is doing exactly that. Yeah, so that's how we're achieving that component. And that way, as it oscillates between them, we get one frame, then the other frame, then the other frame, then the other frame. So you may wish to invert the order, in which case being a bit interesting at the moment. Why is it being interesting? Let's go down here. Oh, and also down here is where I am extending my good friend. This is where I'm actually making the range longer, so that's occurring on just this one. So that's how I'm actually extending the frame length. Otherwise, dealing with that becomes a little bit of a pain for shuffling it back in and out. Alright, so I think that's a pretty good rundown of how it all functions, how it all works, and why it works the way it works. I will say this categorically. The Temporal Interpolation one is a bit buggy because of the hacky kind of approach that we're doing with the append clip and the frame range. It sometimes doesn't buffer correctly, so it can be a little bit dicey as to how well it works. But normally if you're just like rendering from the start to the end of a sequence, it picks it up pretty well. But if you're jumping around in your timeline, don't be surprised if it kind of has a bit of issues as to seeing what the correct data is, because it really relies on these updating correctly. And as you can see at the moment, even though we're on, you know, these are all meant to be on frames, you know, they're not updating as they should to the correct frame. So yeah, and once they're in use they update, but yeah, they don't automatically update. And as you can see when I switch around, yeah, so it can be a little bit problematic for it to buffer the correct frames to do the interpolation between the correct frames, so that's why it's buggy. I haven't come up with a good solve for stabilizing that more than where it's currently at. I have tried a few solutions with not much success, and then honestly I don't see this as being like the method that a lot of people use. This was the one I came up with by accident. I think the Scanline Integration is actually the best method because it spits out the plate back to what it should be in the exact same frame range. Yeah, so same frame range except it's deinterlaced, which is the ideal, plus it handles doing a better job on the extreme frames. Like your first frame and your last frame does a pretty good job of handling those as well. So I think that should cover it for most of you, and I hope you enjoy the tool. Please follow me on YouTube, Tech Adventures, Chris Charlton. Join in on my Patreon. I'll put a link to that as well. And I should have meant to be doing the next tutorial right now for my other tool, which I will be trying to release today, but it's going to be released on my Patreon, which is C Rebuilder. And C Rebuilder, there is a version of it on Nukepedia, sorry, not on Nuke, on Nukepedia. And the new version is much better, much more supreme, and deals with a lot of technical issues that I found and was running into with my older version, and I had to come up with a lot of hack-arounds to kind of make it work in a lot of case scenarios where it should just work. So the new version works incredibly well, and I will be doing another video on that, so please come check it out. And yeah, thank you very much for taking the time to actually watch the video to this point, if you've gotten to this point. Hopefully my editing has salvaged some of this, because I've been trying to do this video for the last few days and I've had multiple issues trying to get there. So yeah, anyway, hope this fills in the blanks for you guys, and I'll catch you next time. Okay, bye. So this is my Patreon as well, just to spruik it all the way. So it's under Chris Charlton Tech Adventures. Yep, so there's the pricing and what you get for each one. So there's a better shot of Rufus. I want to be able to build these tools for artists and make those more tedious tasks are much more easy to get through, and take the technical side out of those components, but also get these tools so that they're not proprietary, they're not owned by anyone specifically, so that you know, you can take them to any place and you don't have to worry about, oh, it's owned by X company. Get some standardization in workflows. Yeah, you like that idea? Yeah.